So this video is about answering number pattern questions, particularly for IB MYP exams. And this one concerns where we have arithmetic patterns. That's ones where the number in the pattern increases by a set amount each time. So for example, in this particular pattern, just zoom in there, it's going +3, +3, just get that right, +3 every time. So the first bit of the question is, write down any patterns that you observe. So I could write down P increases by 3 each time. That should get me a mark. So I noticed that they go odd, even, odd, even. So that could be something to observe. So P alternates between odd and even. Now I noticed that the differences were 3 every time, so the differences between the differences are going to be 0 every time. So you could make a comment about the so-called second differences, the differences between the differences, the second differences are 0. So that's 3 possibilities. You usually get 2 marks for 2 of those. Next bit is predict the next 4 terms of P. So that's just continuing to add on 3. So 19, 22, 25, 28. And then in the exam, I'll just write C table. Okay, next it says find a rule for P in terms of n. So your reasoning is that because these are going up by 3 every time, there's got to be a 3n somewhere in the rule. But if the rule was just 3n, you'd have 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. But the numbers we actually want are 4 more than that every time. So it's 3n plus 4. Now you must write this with the proper notation. So P equals 3n plus 4 is your correct answer to that. So not just 3n plus 4 on its own, not 3 times n plus 4, not n3 plus 4, none of that stuff. Just P equals 3n plus 4. Don't forget to say P equals. If you just write the 3n plus 4 on its own, then you won't get the mark. Okay, moving on. Test and verify your rule. Okay, so test and verify are pretty much the same thing. It's just checking, choking on my words there, that your rule works. So always start off by saying something like when n equals, in fact, put a heading saying what you're doing, so test. When n equals, now test has always got to be one of the low numbers where they filled in the answer for you. So let's say when n equals 2. So I'll underline that. Not very well in this case, but I am working on an iPad rather than on paper. When n equals 2, my rule says, so remember the rule was P equals 3n plus 4. My rule says p equals 3n plus 4. So in this case, if n is 2, that will be 3 times 2 plus 4, which will be 6 plus 4, which will be 10. And it is indeed 10 in the table. So write down the comment, this matches the value in the table, and that should get you your testing mark. So going on to verify, it's almost exactly the same thing, but you're just doing it for one of the higher numbers in the table, one of the ones you filled in yourself. So in fact, in the exam situation, I could just put the heading verify. Just trying to do that on the iPad. Verify. And I could copy paste the whole thing that I did before and just change some of the numbers. So I'll copy that, I'll paste it again, put it down there. There we go. So this time we're going to do it for a higher value, say for n equals 7, why not? So I'll just get rid of some of the stuff I had here. And when n equals 7, my rule says p equals 3n plus 4, so that's 3 times 7 plus 4, so that's 21 plus 4, which is 25, and 25 is the value in the table, so I can write this matches the value in the table. Just highlight my answers there, although I don't really need to do that in the exam if everything's clear enough. Right, it says justify your rule. So there's a couple of things you can do for this. So you can just do 2 more test or verify examples. So again, I'll just paste my test verify thing if I can. I might have to copy it again. So I'll just copy that when n equals 7, copy it, and then I'll paste 2 more of them. When n equals 7, paste that. So I'm just going to do 2 more of those and just change the numbers. So I'll do when n equals 4 and when n equals 6, for example. Boom. Just delete some of that. Okay, so when n equals 4, my rule says 3 times 4 plus 4. So that's 12 plus 4, which is 16. And 16 matches the value in the table. Or when n equals 6, my rule says 3 times 6 plus 4. So that's 18 plus 4, which is 22. And that matches the value in the table. So that didn't take me very long with some copy and pasting, and that should earn me just 1 mark for the test and verify. Another way of approaching the test and verify is in terms of the general rule for the nth term of an arithmetic sequence. So if I just delete all of those to make space. So generally, the nth term is, so there's a formula for this. Nth term is a plus n minus 1 times d. A is the first term and d is the difference between the terms. So here a is going to be, just trying to make this work on my iPad, a is going to be the first term, which is 7, and d is the difference between the terms, which is 3, because they're going up by 3 each time. So in other words, our rule is that we called it P. P equals, just write, so P equals 7 plus n minus 1 times 3. And if I expand that out, I get 7 plus, so n minus 1 times 3 is 3n minus 3. So P equals, so we've got the 3n there, minus 3 together with 7 makes plus 4. P equals 3n plus 4, which is what we had as the rule somewhere there before. Okay, and then a third way you could try and attack the part of the question that says justify or prove your rule might be in the context of the particular example in the question. So it might be some kind of a geometric pattern. No, geometric is a bad word, but some kind of a pattern with objects, and then you might try and explain or justify your rule in terms of the actual context of the question. But that will vary from year to year, so we can't really say anything about that in general terms in this video. Okay, so just to finish off, I just want to talk about how that general rule for the nth term of an arithmetic progression comes about. So you start off with your first term, and your first term we call that a, and then you add something on. So your second term is a plus some difference that you've added on. Then to get the next term, well, you keep adding on this common difference every time. So the next term in the sequence is going to be a plus 2d. The fourth term is going to be a plus 3d. The eighth term is going to be a plus 7d. The 100th term is going to be a plus 99d. It's always one less than the number you're at the sequence because you don't add on for the first one. So generally speaking, the nth term is going to be a plus n minus 1 times d. And that's how you get the general rule that the nth term of any arithmetic sequence is always a plus n minus 1 d.